For thousands of years, navigators in the northern hemisphere have been able to determine their latitude by observing the position of the North Pole star Polaris above the local horizon. Measuring the angle between Polaris and the observer's horizon defines the observer's latitude. Longitude is not so straightforward. There's no natural point of reference like there is for latitude. This presented a serious challenge for sailors far out at sea who could easily get lost. By the late 17th and early 18th centuries, commerce on the high seas was highly important, especially for colonial nations. And as the volume of shipping and travel grew, losses of ships, cargo, and crews grew intolerable. After a particularly horrible shipwreck, the British Parliament passed the 1714 Longitudinal Act, which provided a prize of £20,000, which was a huge sum at the time, for the development of a practical means of determining longitude at sea. The leading scholars of the time, including people like Sir Isaac Newton, who was appointed to be the chair of the Board of Longitude, which would determine the winner of the prize, were convinced that the solution to determine longitude would inevitably involve astronomical calculations of some sort. And so a lot of effort was put into trying to find out a way of using astronomical observations and instruments to find longitude. But this approach was enormously complicated and was nearly impossible to do on a rocking ship at sea. Although the greatest minds at the time were focused on this problem, the solution actually came from a humble clockmaker named John Harrison. Harrison figured out that the best way to determine longitude is with time, or more accurately, by keeping accurate time. So how do we understand the relationship between longitude and time? Well, I'm going to use a kind of a simple example to illustrate the point. So let's imagine that this is the Earth and this is the Sun. We know that in any given 24-hour period we expect that the Sun will trace out a path around the Earth and return to its starting point in 24 hours, and in doing so it traces out the circumference of the world, which is basically a circle, and is essentially equivalent to 360 degrees. Now if we divide that 360 by 24, we're going to end up with 15 degrees per hour, which means that the Sun travels 15 degrees of longitude every hour. So how do we apply this principle to navigation or to figuring out where you are? Well, let's imagine that a sailor starting out from his home port is carrying a chronometer or a clock, and he sets his chronometer to the local time, which is set by looking at when the Sun arrives at its highest point, and that's solar noon. So he sets that clock and he leaves it alone, and some months later he finds himself at some distance from his starting point, and he wants to know how far he's traveled. So the sailor needs to do essentially the same thing again. He needs to know what the local time is. And so again he waits until the Sun, I'll put sun rays this time, arrives at its highest point for that local position. Now when it gets to that local position, to the highest point rather, that's noon, that's 12 p.m. where he's at. So he knows that it's 12 p.m. here, and at that exact moment he also looks down at his watch and he sees that the watch tells him that back where he started from it's 3 p.m. which means that it's been 3 hours since the Sun passed over that horizon and arrived to where he is. Now that's exactly what he needs to know, because we've already established that the Sun travels 15 degrees every hour. So if it's been 3 hours, we simply multiply 3 times 15, and what we're going to end up with is 45 degrees. So he's 45 degrees from his starting position, and we know it's 45 degrees west because the sun travels from east to west. So now he's 45 degrees away from his starting point, and there we have his longitude. John Harrison didn't come up with the principle of longitude's relationship at the time, but he did invent the first clock that could keep time accurately at sea, and this is a picture of it right here. He was eventually awarded the Longitude Prize in 1773, 60 years after it was first announced. In fact, it had to be collected by his son. And the delay wasn't just because of the time it took to develop the solution. It was actually a result of, intentional delay and bias on the part of the Longitude board, who again were very convinced that it had to be an astronomical solution, and they didn't really believe that a clock or a device could actually accomplish the same task. In any case, Harrison's approach 250 years later is still the basis on which we've established time zones, and of course we can still establish longitude just by knowing the time difference between our home port or our prime meridian and the place we are currently.